This question says 140 milligrams of an unknown protein are dissolved in enough solvent to make 5 milliliters of solution. The osmotic pressure of the solution is measured to be 0.09 atmospheres at 25 degrees C, and then it asks us to calculate the molar mass of the protein. These questions could be very challenging because, generally speaking, if one wants to calculate molar mass, we use the periodic table and we add up the mass of the elements. But in this case, we don't know what the protein is, so we can't add up the molar mass of the elements. So we're going to have to use some other information. Fundamentally, molar mass is grams per mole. Well, we have the mass of the protein here, so we need to find the moles of the protein. And we're going to have to use some of this other information to find the moles of the protein. And specifically, we're going to have to use the osmotic pressure. The formula here is the osmotic pressure, pi, equals the molarity times R times T. This equation should be familiar. This is the same as PV equals nRT, except molarity is moles per liter. So this is both N and all V just combined together. So pressure equals mRT. So we have the osmotic pressure, 0.0900 atmospheres, equals M, that's what we're looking for. R is 0.08206. That's liter atmospheres per mole K. And T is the temperature in Kelvin. So we cannot use the 225. We have to convert that to Kelvin. And when we do, we get 298 K. So the molarity, we multiply these two and divide into this one. The molarity is equal to 0.00368 molar to 3 sig figs. Now, this just gives us the molarity. It doesn't actually give us the number of moles. So we need to convert liters of this solution to moles of the protein. So, starting with this in liters, divide by 1,000, 0.00500 liters of solution times, this tells us that there are 0.00368 moles of protein in 1 liter of solution. We find there are 1.84 times 10 to the minus 5 moles of protein in 5 milliliters of this solution. Now, we have grams, well we have milligrams, and we have moles. So we take our milligrams, divide by 1,000, 0.140 grams, divide by the moles, 1.84 times 10 to the minus 5 moles. And when you do all that math to 3 significant figures, you get 7610 grams per mole. Now, I would strongly recommend putting this in scientific notation because here the sig figs are ambiguous a little bit, whether or not this is a sig fig or not. So if we put it in scientific notation, it's not ambiguous. 7.61 times 10 to the 3 grams per mole. So typically, we may not be finding molar masses this way. Typically, we use the periodic table. However, this is a way to find the experimental molar mass of this compound.